Hi, everybody. Welcome to Chapter 2. In Chapter 1, we talked about whole numbers, right? Numbers that are just whole amounts. They have no sign really of their own. They're all positive numbers. In Chapter 2, we're going to talk about integers, which are, as we'll see, they are the positive and negative numbers. And so all the whole numbers that we got in Chapter 1, we can make negative, and we will have the other half of our what we'll call a number line later, and we'll have all of the integers that we need to move forward. So we're going to start with 2.1. So in 2.1, we're going to focus on understanding positive and negative numbers, comparing them, and then also talking about an important concept called absolute value. And so you can see some of the keywords that we're going to talk about, and let's go ahead and look at some examples. So we're used to the idea of equality. For instance, 3 equals 3. But what about inequality? Inequality is the idea that, well, instead of being totally equal, the sign looks like this because one of the bars is tilted toward the, well, instead of thinking of it tilting toward, I like to think of it as it opens toward the larger number. So let's say if this is 3 on this side, this could be 2 on that side. So the way we read this one is 2 is less than 3, which makes sense. 2 is less than 3, right? If you have 2 of something and someone has 3 of something, they have more. But it's still a true statement to say, right? It's not true to say 2 equals 3, but it is true to say 2 is less than 3. I'm going to thicken my line here a little bit. So there we go. It's a little thicker. We can read it a little better. So the way we read this is when the sign points to the left, right? When it points to the left, it's less than. And when it points to the right, it's greater than. And so let's look at some examples. So let's have a look at example A. 3 is less than 5. Is this true? That's true. 3 is always less than 5. It doesn't say by how much less. It just has to be a little bit less, and it's less than 5. How about B? 0 greater than 100. 0 greater than 100. Right? This is not true. 0 is not greater than 100. 0 is less than 100. So that wouldn't be a true statement. What about C? Negative 3 is less than 5 is read negative 3 is less than 5, right? And of course, I can't read it without saying it correctly, right? Because we have to know what it means. So it is a true statement because negative 3 is less than 5. Let's say I owe someone $3 and someone else has $5. Who is wealthier at the moment? Who has more money? Well, the person who has $5 is better off than someone who owes $3. Another way to think about this is a number line. So we draw a horizontal line, we put 0 right at the center, and we say on the right side, increasing from 0, are all the positive numbers. And on the left are all the negative numbers. And so this would be 1, 2, 3, 4, and 5. And this would be negative 1, negative 2, negative 3, negative 4, and negative 5. And what we're saying when we're comparing integers is we're looking for the one that is on the left on the number line. In this case, -3 is on the left on the number line. It's on the left of 5. And we kind of knew that because it was negative, and we know that all negative numbers are smaller than all positive numbers, right? It's always better to have $1 than to owe even $1. So this is a true statement, and we can sort of think about it on a number line. Let's look at the next one. -5 is less than -2. Is -5 less than -2? Okay, this is a little trickier, right? They're both on the left of 0. They're both negative numbers. Which one is more negative, really, is the question. Which one's smaller? So is it better to owe someone $2, or is it better to owe someone $5? Well, owing $2 is better, so this is a bigger number. And so it is true to say -2 is less than, -5 is less than -2. -5 is less than -2. Now that also means we can turn it around. -2, but instead of less than, now the symbol has to continue to face whichever way it was facing. So if it's facing the larger number here, it has to continue facing the larger number there. Sometimes teachers like to teach this as the symbols are alligator mouths. And the alligator always wants to eat the bigger number. So that's kind of a nice way to think about it, is the alligator's always going after the bigger fish, right? And it's going to leave the small fish behind. So that can be a helpful way to think about it if you're having trouble reading it and you want to make sure that the problem is correct. Another way to remember how to say them is that this is the less than symbol. It points to the left, but it also sort of looks like an L. Whereas the greater than symbol points to the right, and greater has an R, has 2 R's in it, in fact, and it kind of maybe looks like it could be part of the G. So we've got less than and greater than symbols. Okay. Now let's talk about absolute value. The absolute value of a number is going to be the distance from 0 to that number on the number line. So, in other words, a good example of this might be to think about a city block. So let's say you're here, and you're not sure if you should go 2 blocks east or 2 blocks west. Now, going east we could think of as sort of positive, and going west we could think of as negative in terms of directions on the number line. But if you have to go 2 blocks in one direction, does it really matter to you whether you go east or west? Not really. It's the same distance. And so absolute value is the absolute distance from 0 on the number line, regardless of the positive or negative sign. And in fact, the absolute value is the number without its sign. So let's look at the examples. So A, the absolute value of 5. So the absolute value of 5 is going to be the distance from 0 to 5 on a number line. So if I just make this my number line here, and I'll make this my 0, 1, 2, 3, 4, 5. If I start here at 0 and I count to 5, I have to go 1, 2, 3, 4, 5 units. And in fact, that's why 5 is called 5, right? Because it's 5 units from 0. So the absolute value of 5 is 5, the number without its sign. Let's have a look at some more here. How about B, the absolute value of -3. So let's go over to our makeshift number line here, -1, -2, -3. So I want to go from 0 to negative 3, the distance is 1, 2, 3 units. So the absolute value of negative 3 is 3, because it's sort of like saying, how far did you walk? Well, you're telling me you walked in the west direction, but I just want to know how far you went. Well, you went 3 blocks. Okay, that's good enough. Let's look at C, the absolute value of negative 7. Well, negative 7 is 7 units away from 0. So the absolute value of negative 7 is 7, the number without its sign. Now, an important and related concept to absolute value is the idea of an opposite. So the opposite of a number is the same number with the opposite sign. In other words, it's exactly on the other side of 0 from the number. So if we think about our number line again, oops, it's not a very straight line. Let's see if we can draw a straighter line. Here's 0, here's 1, 2, 3. What is the opposite of 3? What number is exactly 3 units away from 0, but with the opposite sign? It has to be negative 3. So the opposite of 3 is negative 3. Now, the reason that this is an important concept is because if you take two opposites and combine them, whether you start with the positive 3, right? We don't really write the plus when it comes first, but we sort of know it's there. Whether you start with the positive and you take away 3, or you start at negative 3 and you add 3, you're going to get back to 0, right? Because if I start at 3 and then I want to take away 3, that means moving to the left, to take away, to go less than. So if I go 3, I'll get back to 0. Now, if I start at negative 3, and then I add 3, that means I'm going to the right. I'm making it greater. And so I'll go 1, 2, 3 units to the right, and I'm still at 0. So when you combine opposites through addition and subtraction, like this, then you get 0. And that's an important concept. So 0 is the only number that doesn't usually have a sign attributed to it, right? 1, negative 1, you have to make the distinction. But 0, whether you add it or subtract it, doesn't make a difference. All right, so if the opposite of a positive number is a negative number, what's the opposite of a negative number? Well, the opposite of a negative number is going to be a positive number. So if I start at my number line again, and I start at negative 3, if I start here at negative 3 and I want to know, well, what's the opposite of negative 3? Because I know the opposite of 3, right? The opposite of 3 is negative 3. What's the opposite of negative 3? What number is exactly the same absolute value and same distance from 0, but with the opposite sign? That's positive 3. So this is where the idea comes from that a negative and a negative make a positive, because when you multiply two negatives, you get a positive. When you take the opposite of a negative, you get a positive. And so that's where that idea comes from. Now, let's give some opposites of some numbers here. So A through E, you can see the answers are already there, but we're going to do them together. So 5. Okay. What's the opposite of 5? The opposite of 5 is negative 5. How about B? 7. Well, the opposite of 7 is negative 7. C is 1. The opposite of 1 is negative 1. And D for negative 5. The opposite of negative 5 is 5. right? If you owe $5, what's the opposite of owing $5? Having $5. And that's what this says. E. What's the opposite of -8? The opposite of -8 is 8. So hopefully that cleared up the sort of the rule that we think about whenever we have a negative and a negative next to each other in this situation. Okay, so let's simplify some problems with absolute values as well. So let's look at A. Negative absolute value of 8. And what they want us to do is simplify this. So can we make it any simpler? Well, I can take the absolute value of a number. So what I'll do is I'll bring the negative down and I will resolve this part here. What is the absolute value of 8? The absolute value of 8 is 8, the number without its sign. Now you might be saying, well, but it's got a negative out in front. But the negative was in front of the absolute value bars, not contained within it. Now let's have a look at B. Negative, the absolute value of -10. So the first thing I have to deal with is the absolute value. It's like a grouping symbol. So I'm going to bring down this negative. So I'm going to say whatever I get from this, whatever the absolute value of -10 is, I've got a negative in front of it, and I'm going to have to resolve that afterward. What is the absolute value of -10? Remember, the absolute value of a number is its distance from 0 on the number line, regardless of its sign, the number without its sign. How far is it from 0? Well, 10, whether it's 10 or -10, is 10 units from 0. So the absolute value of -10 is 10. So this negative, this negative here, that's the one that got resolved. And the absolute value of a negative number is a positive number. But this other negative sign had to come down. And so they don't cancel each other out because absolute value bars are not like parentheses in that you can't distribute the way you can distribute with parentheses. You have to resolve the absolute value before distributing the negative in this case. Okay, so let's define what an integer is. So integers are the set of numbers that are all the whole numbers, and that includes 0, right? And their opposites, so all the negatives. And so the way to think about integers is they are all the tick marks on our number line. And they keep going. They don't stop at 5 or -5. They keep going in both the positive and negative direction forever. They actually go to infinity. So there's an infinite number of integers. In theory, in practical use, of course, we use numbers that are typically in the tens, hundreds, thousands, and sometimes we go into the millions and billions as examples. But for the most part in math, we're focused on a lot of these smaller numbers, actually. So we don't go way out to infinity or way out to negative infinity. But we can, and that's the idea of integers. So let's review some of the concepts here in 2.1. So part A here. Write the statement 3 is less than 5 in symbols. So 3 is less than 5. And you can think of it a couple of different ways. The less than is an arrow that points to the left, or you can think of it as an alligator trying to eat the bigger number. Those are both good ways to think about it. The other way to think about it is it's like an equal sign that's been tilted to prefer the bigger number. Now you might be thinking, well, the bigger number should be heavier and it should be weighing down the pointy end, but that's not how the symbols started, and so we use them to be open to the bigger number, to prefer the bigger number. All right, let's look at B. Oops, capital B. What is the absolute value of a number? The absolute value of a number, and sometimes we will abbreviate it ABS, the absolute value is distance from 0. So 0 is the center of our number line, the center of the integers. And the absolute value of a number is the number's distance from 0. In other words, the number without a sign. That's kind of a helpful way to think about it. So if you have the absolute value of a number, just drop the absolute value bars and drop any sign that's inside and take the number out as its distance from 0 as a positive number. Okay. C. Describe what we mean by numbers that are opposites of each other. Well, I gave you a hint to this earlier, right? It's numbers are opposites to each other when they are the same distance from 0 on the number line, or, in other words, they have the same absolute value, or when you combine them, you get 0. So, same absolute value. That's what numbers are when they're opposites. So they have the same absolute value, but different signs. So an example would be 3 and -3, or -3 and the opposite of -3. Right? These would also be opposites of one another. Okay. Part D. If you locate two different numbers on the real number line, which one will be the smaller number? There's 3. There's -5. I've located both of these numbers on the number line. How do I know which one's smaller? Well, if they're properly located on the number line, then the number on the left is the smaller number. So that's how I'll answer this. If you locate two different numbers on the real number line, which one will be the smaller number? The number on the left. Okay, so if you have any questions about that, please let me know. Otherwise, I'll see you in 2.2.